Hi, today we are looking at section 5.5, which is dealing with Z-scores. So we can use Z-scores to compare data from two different sets. So even if we have standard deviations that are different and means are different, it enables us to compare data. Now, our standard normal distribution has a mean of 0 and standard deviation of 1. However, that would be our standard normal distribution. We'll have ones that are not normal and our mean is a different value and our standard deviation is a different value. So to calculate a Z-score, which is a standard value that indicates the number of standard deviations of the data above or below the mean, we have a formula Z is equal to, or Z-score is equal to our data point minus our mean divided by our standard deviation. So we'll do a couple examples of calculating the Z-score. So this first one, we have a mean of 10. So that would be this symbol. Standard deviation is 6, which is this symbol. And our data is just X. Now our formula is Z is equal to X minus mu over our standard deviation. So we've got Z is equal to our data point of 12 minus our mean of 10 divided by our standard deviation of 6. So we'll calculate our numerator. First, we've got 2 divided by 6. So that gives us a Z-score of 0.33. Next example, calculate the Z-score. We have a mean of 10, a standard deviation of 2, and a data score of 8. So once again, our mean is represented by this symbol, standard deviation by this one, and data by this one. Now our Z-score is equal to our data point minus our mean divided by our standard deviation. So we have Z is equal to our data point, which is 8, minus our mean divided by our standard deviation. So in this case, we have -2 over 2. So our Z-score is -1, which means our data is 1 standard deviation below the mean. Now, in a previous section, we talked about the bell curve and what percentage of the data was in each section. So if our standard deviation works out as exactly 1, 2, or 3 standard deviations, we can use that to figure out what percentage of the data it is greater than or less than. If it's not, what we can do is use a Z-score table, which there's one located on page 592 and 593 of our textbook. And we can use it to determine exactly what percentage of the data is less than our value and what percentage is lower. Okay, so for example, calculate the Z-score when X is equal to 119. Our mean is 100 and our standard deviation is 15, and then find the percent of data that it is greater than. So we've got Z is equal to our data point minus our mean divided by our standard deviation. So we have Z is equal to 119 minus 100 divided by 15. So we have Z is 19 divided by 15. So Z is 19 divided by 15, and we'll keep 2 decimal places because our table that we go to has 2 decimal places. So we've got 1.27. Okay, so we have a Z-score of 1.27, which means this data point is 1.27 standard deviations above the mean, but that doesn't really tell us what percentage of the data it is larger than. So for that, we'll look at our data table. Now, I have scanned in the one that is on the pages mentioned on the previous slide, and we'll look up 1.27. So if we look at this table, we have essentially our first 2 digits here, our ones column and our tenths, and then over here we have our hundreds column. So we are looking for 1.27. So we've got 1.2 here, so we'll have to go across to where our last digit is a 7. So as you can see, we've got 1.2. We match that up to here. We've got our 7. So it's this value here. It's at 0.8980. Now this is our percentage as a decimal. So it's 89.8%. Because we'll just shift our decimal over by 2. So it is greater than 89.8% of the data. If we wanted to know what percentage is less than, we would just go 100 minus this, and that tells us how much data is larger than this.